So our next section here is calculus. We move straight to chapter 7. So this is a continuation from your grade 12 plus your N3 calculus. Okay. So what have you done previously in grade 12? You found the first derivative of a function, whether it's a straight line, parabola, or any power of x. Basically, you differentiated something that looked like this here, kx to the power n. So what did you do? You differentiated it, plus there were applications on calculus where you had to sketch the cubic graph, which we will be doing again. However, now you see the table of derivatives. There's not only kx to the power n, you must be able to differentiate anything here. Any graph here that you are able to sketch, you must be able to find the first derivative of. Okay. So here you can see I got 1, 2, 3, there's quite a few here. So now, this is your table of derivatives. In the first column here, I have all the original functions. This is basically the questions. And next to it is the answer, basically the solution on how to differentiate it. Right, so if we go to number 1, which you have been doing previously, this is a number like 2x squared. So k and n. So I wrote down here all k, n, a, and e. Wherever you see that in the table of derivatives, they represent constants. They don't change. They are that's just a number. So here, remember when you differentiate kx to the power n, then the first derivative is k multiplied by n, x to the power n minus 1. Right, so this is applying the rules straight from your table. This is not first principles. Right, so now you come across new things like the derivative of sine, cos, tan, cosec, sec, cot. Then you got your two exponential graphs here. Then you have your two log graphs. This is k log f of x to the base a, and this is k ln, that's ln or natural log. F of x, your base is not shown. I'm going to explain that to you in a few minutes. So now, what you need to do is the best thing. If you're moving up in engineering, you're carrying on to N5 and N6, you will be dealing with this. Basically, will be the whole syllabus. So it's best to memorize this table here, okay? Because there's many more rules that you're going to learn, but you will always be using this table of derivatives. And if you have it in your head, then it'll be easier. Remember, differentiation is 20% and integration is another 20%. So that's calculus is 40% in your exam. So to make sure you get full 40%, at least memorize this table. You write it down over and over again until you know it. So we're not going to get into first principles. We're going straight to the table. You have been dealing with first principles in grade 12 and N3. So let's recap. Let's do a few examples. This is revision of N3 work or grade 12. Right, so the question is, determine the first derivative. So here I'm giving you everything. This is an equation, y in terms of x. So let's deal with number 1. So here, for number 1, first of all, if you want to differentiate, make sure that all terms are in standard form. Standard form means it must look like something on the left-hand side of this table. So let's look at term 1. Term 1 is in standard form. Here's your kx to the power n. Term 2 also in standard form, kx to the power n. Term 3, term 4. So they're all in standard form. I do not need to manipulate anything there. I can differentiate it straight away. So when I differentiate, I'm going dy over dx. Right, so basically what's happening here is you are finding d over dx of both sides. Let me just rewrite this here. So that's d over dx of y, so that's the left hand side. Whatever you do on the left hand side, you do on the right hand side. D over dx of 3x squared plus 2x to the power minus 4 plus 5x plus 2. So what does this mean? D over dx, I'm differentiating y with respect to x. Okay, so now I have dy over dx. So now d over dx of 3x squared. The derivative of 3x squared. So what do we do here? Is we multiply the coefficient by the exponent. So that's going to be 3 times 2. Write down your base, which is x, and take your exponent and subtract 1. So there is the rule here. Multiply the coefficients by the power. Take the same power, subtract 1. You know, you've been dealing with this from grade 12. So here, this is going to be a plus 2 times minus 4, and then you write down the base, which is x, and then minus 4 minus 1. Here, the derivative of 5x, so there is a shortcut that you can use here. So basically, if y is equal to kx to the power 1, if y is equal to kx to the power 1. So here clearly my exponent is a positive 1. Then the derivative here, so I can write it as y prime, it means the same thing. So I can write it as dy over dx, f prime x, or I can write it as y prime. They all mean the same thing. So I will multiply, this will be k times 1, x to the power 1 minus 1. Can you see that? So therefore, k times 1 is k, x, 1 minus 1 is 0. So I got k times x to the power 0. What is x to the power 0? It's 1. So k times 1 is k. So basically the result will always be k if your exponent is a positive 1. So what does that mean now? It means that if I got y is equal to 6x, I do not have to go and do it the long way. I know that k is 6 here. Can you see that? If your exponent is a positive 1, the derivative here will just be 6. So then if I have y is equal to minus 13x, if I want to find the first derivative of minus 13x, it's going to be minus 13. So it only works if your exponent is a positive 1, that's a shortcut. So in this case here, the derivative of 5x will be 5. Now, what about the derivative of a constant? The derivative of a constant, let's write it down here. So if I got y is equal to k, k is a number, a constant. So now, if I multiply it by 1, am I changing the question in any way? No, I'm not. 1 is actually x to the power 0. X to the power 0 is 1. So now if I differentiate here, I'm going to go k times 0, x to the power 0 minus 1. Can you see that? So therefore, y prime is equal to, the fact is 0 minus 1 is minus 1. But this 0 is being multiplied by all the bases here. So it doesn't matter what the exponent here is, 0 times anything will be 0. So therefore, shortcuts, the derivative of a constant is 0. Now, you do not have to go and write down 2 minus 1. You do not have to go and write down 3 times 2. You can go one time to the step here and write down your solution, because it's taken that you know that the rule 3 times 2, that will be 6x to the power 1. 2 times minus 4 is minus 8x. Minus 4 minus 1 is minus 5, and then we got our plus 5 there. And I will advise you to copy down that 0 even in your final answer, because whoever is marking your paper needs to see that the derivative of a constant is 0, not a blank space. You understand that? So let me just simplify my answer there. That will be 6x minus 8 all over x to the power 5 plus 5 plus your 0. So that is your first derivative. I'm simplifying, I'm rewriting my exponents, rewriting my terms with positive exponents, but you will only do that if it is required. So that is the first one. Let's deal with the second one. So I got y is equal to 2 over x plus 3 over 4x squared minus 5 over 2x to the power minus 3 plus the cube root of x to the power 5. Right, so now, still dealing with some grade 12 revision here, or N3 revision, we have many terms, 1, 2, 3, 4 terms. So now, if we need to differentiate, we need to make sure that all terms are in standard form. That means they need to be looking like number 1 here, which is kx to the power n. At the moment, we are still dealing with only number 1. Right, just to recap. So, here, this is not in standard form. Your standard form is k multiplied by x. Now you have a number divided by x. Okay. So at this point, I did not show you the quotient rule, so we are not using the quotient rule here. We are still going to learn the quotient rule in a few minutes, where you can apply a rule for differentiation regarding division and then product rule for multiplication. For now, we have to rearrange using our exponents. So, y is equal to, I got 2 over x. So, remember, what's the power here? If it's not shown, it's a positive 1. So, if I take x to the top, the sign of the exponent will change. That will become a negative. Alright. Here, I got 3 over 4x squared. So be careful, this is a common mistake that students make. You do not take 4 to the top, because 4 is being multiplied by x squared. So 3 over 4x squared, what does that mean? 3 over 4x squared, let me just write it down here. So if I got 3 over 4x squared, this means it's 3 over 4, and it's 3 over 4 in the bottom, x squared. This means it's 3 over 4 multiplied by 1 over x squared. You need to understand how to rewrite a fraction times a fraction. So here's a fraction 3 over 4 multiplied by 1 over x squared, which resulted in 3 on the top, because 3 times 1 is 3, and in the denominator 4 times x squared is 4x squared. So all you're going to do is take x squared to the top. So in this situation here, it's going to be 3 over 4 times x to the power negative 2. When you take x squared to the top, the sign of the exponent changes. Here we got minus 5 over 2. I will take x to the power negative 3 to the top. It will be times x to the power positive 3. You got that? Here, this here is the cube roots. So here we have the cube root of x to the power 5. So I need to rewrite this in exponential form. So how do I do that? Remember that I will write my base, which is x. Now, this 5 and 3, you will write it as an exponent, which is a fraction. What must you remember here? Is that the root is outside. The root will always be the denominator. So this exponent will always be the numerator when you convert it. So therefore this will be 3 in the bottom, 5 at the top. So it's x to the power 5 over 3. Can you all see that? Now, all terms are in standard form. So remember, standard form. Standard form is k multiplied by x to the power n. Now I can find the first derivative there, dy over dx. So dy over dx now, this is all differentiation straightforward. 2 times minus 1 will be minus 2x, minus 1 will be minus 2. Here, 3 over 4 times minus 2 is a positive times a negative. That will be minus 6 over 4. X minus 2 minus 1 is minus 3. Here, we got a negative 5 over 2 times 3. That will be minus 15 over 2. X and 3 minus 1 will give me 2. Are you clear with that? Then the last one here, you got a 1 in front, so it's 1 times 5 over 3. So 1 times 5 over 3 is 5 over 3 x, then 5 over 3 minus 1. That means 5 over 3 minus 3 over 3, which is going to be 2 over 3. Alright, so this was, you can see, straightforward. Now I'm going to simplify my final answer. I'm going to rewrite it with a positive exponent. So my dy over dx is equal to, that will be minus 2 over x squared. So what did I do? I took the base to the bottom, sign of the exponent changed, and this is going to be 6 over 4. 6 over 4 can be simplified further, 3 over 2. So that's going to be my minus 3 over 2 x to the power 3. Notice I took the base x to the denominator and the sign of the exponent changed. Here, this there's nothing to do here. Minus 15 over 2x squared. Here I'm going to rewrite it back in third form. I'm going to rewrite that back in third form. So this here is a 2 and this will be 3. So that is simplified. Right, have a look at that. Check. Any problems there? Right, so moving on to our next example, number 3, still dealing with last semester's work, grade 12 or N3. We need to simplify this here. This is not in standard form. So, in order to simplify this, I need to square them. So on the top I have something in the form of a plus b squared. So which could be done in one step, a squared plus 2ab plus b squared. I can square the numerator. So y is equal to x squared all squared plus 2 times x squared times 3 plus 3 squared. Okay. All divided by x to the power 3. So here I got x squared all squared. This can be written as x to the power 2 times 2 is 4. When you have a power raised to a higher power, multiply the exponents. And here I got plus 2 times 3, that will be 6x squared and plus 3 squared, which is 9. All divided by x cubed. We still got a problem because there's division. We are dividing, so we need to separate them. We need to divide. So what I can do is I can separate this into 3 fractions because there are 3 terms in the numerator there. Can you see that? 3 terms in the numerator, so therefore this can be written as x to the power 4 over x cubed plus 6x squared over x cubed plus 9 over x cubed. And finally, we can simplify. So, exponent laws are very important. If you do not know the exponent laws, you cannot simplify what we have here. So, you must be able to apply these exponent laws. So, now I'm going to simplify. So, what do I have now? Here I am dividing and the bases are the same. So if I have x to the power p divided by x to the power q, when I'm dividing and the bases are the same, I write down the base once and subtract the exponent. That is your exponent law. So here, that's exactly what I'm going to do. X 4 minus 3, which is 1, plus 6 divided by 1, which is 6. Here, 2 minus 3 is minus 1. It's always top power minus the bottom power. Here, all I will do is take this to the top. It becomes 9x to the power negative 3. Can you all see that? Now, finally, I can differentiate. So I'm going to go dy over dx. Okay, so remember, I'm differentiating both sides with respect to x. So the derivative of x to the power 1, remember we just did that. If you have y is equal to kx, the derivative is just going to be k when your power is a positive 1 only. So what's in front here is a 1. So the derivative of 1x is just 1. The derivative here, 6 times minus 1 is minus 6x, minus 1 is minus 2. Here, 9 times negative 3 is minus 27x, minus 3 minus 1 is minus 4. Now, I'm going to simplify and write my answers with positive exponents. So therefore, my dy over dx is equal to 1 minus 6 over x squared minus 27 all divided by x to the power 4. Alright, so now that was revision of N3 work plus grade 12 stuff. Now let's deal with the next example. So what do we have now? We have 2 sine 3x. So y is equal to 2 sine 3x minus 4 cos 5x plus 3 tan half x. Okay, so now, just like with your variable x, x to the power n, it must be in standard form. The same applies for anything. So these are all standard form. They are all in standard form. They appear on your table of derivatives. Okay, now, here you read this. This is 2 sine. Now notice, how do I have it written down there? You got your y is equal to k sine and then your function of x there. So that's f of x. So if we compare here now, the number in front there is 2 sine of f of your function of x here is 3x. Can you all see that? So when we differentiate something, when you differentiate, so that's going to be dy over dx. The derivative of k sine f of x is going to be k cos of the f of x. So basically you're differentiating sine of your function, which the derivative is going to be cos of that same function, multiplied, multiplied now by, you find the derivative here and you write down your answer here. So basically it's multiplied by the derivative of f of x. Everywhere on that table you can see you always have f prime x. That means differentiate what you have here, write down your answer. Okay, that's how we deal with this. So let's deal with this one. So I've got dy over dx. So the derivative of 2 sine 3x is going to be 2 cos of 3x. So basically what's happening is you're differentiating sine, which becomes cos, times now you're differentiating 3x. The derivative of 3x is going to be 3. That's all. Simple. That's how you apply the formula. So the same goes for cos tan. Look at your table of derivatives there. So the derivative of cos. Now I've got a minus 4 there. Okay, remember it's minus 4 times cos 5x. So the derivative of cos, if you look at your table, let me just write this down. Okay, since the table is not in front of you, so if I've got y is equal to k cos f of x, then the derivative there, dy over dx, the derivative is going to be minus k sine f of x. So the derivative of cos is minus sine times f prime x. So here, the derivative of cos of 5x is going to be minus sine of 5x. Or if you wanted to keep the 4, it doesn't make a difference, all multiplication. Right, but the fact is the derivative of cos is a negative sine of the function of x times now differentiate what's here and write it down here. So the derivative of 5x is 5. You're clear with that? Now term 3 is tan. So let me just rewrite tan for you there. So if I got y is equal to tan f of x, then the derivative of tan is going to be sec squared f of x times f prime x. So the derivative of tan of half, 3 tan of half x will be 3 sec squared of the function of x, which is half x. So we at this point here, times. Now differentiate f of x, write down your answer here. What's the derivative of half x? It's just half. Right, you're done now. That is it. It's just to simplify, multiply the constants. So 2 times 3 will be 6 cos 3x. Here, negative times negative is a positive. 4 times 5 here is 20 sine 5x. Here, we got 3 times 1 divided by 2, which is the same as 3 over 2 sec squared half x. And that's basically it. So differentiating using the table of derivatives, very easy. Okay. What is number 5? Now we've got 2 cosec 5x. So here I got 2 cosec 5x minus 2 sec x over 3 and then plus half cot or cotan of 2x over 3. Right, so what are we dealing with now? We are dealing with cosec. So if y is equal to k cosec f of x from your table of derivatives, then the derivative of cosec is going to be a negative cosec f of x times cot f of x times f prime x. That is the formula to differentiate cosec. What is the next one? We have sec. If y is equal to sec f of x, then the derivative of sec is going to be sec f of x times tan f of x. And always after you differentiate your trig function, then it's the derivative of f of x there, which becomes f prime x. What's the last one then? Cot. So if y is equal to cot f of x from your table of derivatives, then you differentiate cot, that's going to be negative cosec squared f of x, and then times f prime x. Right, you write it down 100 times and it's in your head. Right, it will help you to get full marks here. Right, but obviously not it will help you, but in order to get full marks, you have to know simplification, how to rearrange something. And you have to know your exponent laws. So now let's differentiate this. So I've got y is equal to 2 cosec there. So dy over dx. So here is the formula. I've got 2 cosec f of x. So there's my 2 there. That's 2 cosec 5x. F of x is 5x. Alright. Differentiate. The derivative of 2 cosec 5x will be negative 2 cosec 5x times cot 5x. So where am I now? I'm going negative cosec times cot, and then at the end, always f prime x. So that's going to be times f of x is 5x, so f prime x is the derivative of 5x, which is 5. So that is cosec. Here, the derivative of sec, so that's minus 2. When you have, where is sec? There's sec here. The derivative of sec is sec f of x times tan f of x. You can see that? So the derivative of sec there is going to be sec 1 over 3x times tan 1 over 3x times the derivative of 1 over 3x, which is 1 over 3. What else? Cot. Where is cot? There's cot here. The derivative of cot of f of x is going to be negative cosec squared f of x times f prime x. So the derivative of positive half will be negative half cosec squared of 2 over 3x times the derivative of 2 over 3x, which is 2 over 3. So that's basically it. Let's simplify. So what do I have? I'm just going to multiply the constant. So that's going to be minus 2 times 5x minus 10 cosec 5x times cot 5x. Then term 2, what do I have here? Minus 2 times 1 over 3. So that's going to be minus 2 over 3 sec 1 over 3x tan 1 over 3x. Here, what do I have here? Minus 1 over 2 times 2 over 3. So 2 and 2 cancel. I end up with minus 1 over 3 cosec squared 2 over 3x. That is just a simplification. You make sure you know these. This must be in your head. Alright, so I'm going to erase the board so we can deal with the next few examples there. Right, number 6. So here we got 4. Be careful, this is not 43. This is 3 to the power 6x, and this whole thing is multiplied by the number 4. That's how you read it. It's 4 multiplied by 3 to the power 6x. This is 2 multiplied by e to the power minus 2x. Okay, e is a constant. And here we got 4 log 3x base 5, yeah? Minus 6 ln, that's natural log of 10x. Right, so they are all in standard form. We are dealing with these ones here. You can see that. We are dealing with k times a to the power f of x, k times e to the power f of x, k log f of x to the base a, k ln f of x. That's the ones we are dealing with now. Alright, so here I'm going to go dy over dx. So, how do you differentiate now? You look at, there's a table in front of you. When you differentiate your exponential function, step number 1 is to copy it down as it is. So, k times a to the power f of x is k times a to the power f of x. That is step 1. You can see it. Times, now you put ln, that's natural log of the base. What is your base? 3. You can see ln of a. A is the base there. Can you see that? Times, now the last thing you're going to do is the exponent is f of x. So you differentiate the exponent and write down your answer there. So multiply it. So that's times 6. You clear with that? So that's going to be ka to the power f of x times then a times f prime x. This one. When you're doing this, your base is e. So basically, you can use the above formula, ka, the one that we just used, but when it's e, there's no need to put the ln part there. So we got plus 2 times e to the power minus 2x, and then you don't have to put down ln of e. Like here I put ln of the base. Here your base is e because ln of e is the same as log of 10, which is 1. So that's why it's unnecessary to put down ln e. You go straight for f prime x, the derivative of minus 2x is minus 2, as you can see. There's it, ke to the power f of x times f prime x. Right, so here, this one, this is k log f of x to the base a. So the rule is, you got your 4 times, now this is going to be a fraction. Okay, so the derivative there, this is f of x, so the derivative is f prime x, which is 3. As you can see, there's a jump. K f prime x, all divided by f of x now. So I need to divide by the same f of x there. So that's f prime x divided by f of x, also times natural log of the base, ln of the base. Your base there is 5. You can see that ln of a. So there's it, ln a is the base of your log. Alright, so now this one here, minus 6 times, it's almost the same formula. Almost. In fact, the base here is not shown. If your base is not shown for natural log, it is e. So the formula is f prime x divided by f of x. So take this f of x, just like how you took the f of x, copied it here. Take 10x, copy it in the denominator, differentiate this and write down the result there. F prime x divided by f of x. And that's how we use those ones. So now, what's to simplify here? So here, there's nothing much you can do except there's a 6 there and there's a 4 there. This is not 3, this is natural log of 3. So you cannot multiply this 3 by 6 there because it is not 3. It is natural log of 3. But you can go 6 times 4, which is 24 times 3 to the power 6x ln 3. Here, I can go positive times negative, so it will be minus 4 e to the power minus 2x. Here, 3 and 3 will cancel, so I end up with a plus 4 divided by x natural log 5, ln 5. Here, 10 and 10 will cancel, you end up with minus 6 divided by x. You do not have to make the exponent positive here, because this is the standard form for your exponential. So that was number 6. Okay, number 7. Number 7, we need to simplify here. So the numerator is sine 2x. So in this case, we need our double angle formulas from Trigonometry grade 12. So let me write it down for you. So this is trigonometry. Double angles. So we need to be able to write down the equivalent for sine 2x. So sine 2x, the double angle formula for sine 2x is going to be 2 sine 1x cos 1x. Then the double angle formula for cos 2x, there's actually 3 formulas for cos 2x. First one is cos squared minus sine squared. So remember, there's a 2 there, that becomes a 1 and a 1 there. Then the second one is 1 minus 2 sine squared. And then the last one for cos 2x is 2 cos squared x minus 1. And then we also have a formula for tan 2x, which is going to be 2 tan x all divided by 1 minus tan squared x. Right, so those are the double angle formulas from trigonometry. We might have to use it here. In fact, we are going to be using it here. So the problem is that this is a double angle and this is not, it's just a single. There's just one here. Can you see that? So we cannot go sine over cos is 2. Only sine over cos, if the angles are the same, then it's equal to tan. Okay, so here I will have to apply my double angle formula. So I've got y is equal to sine 2x. There's only one formula for sine 2x, which is 2 sine x cos x, all divided by cos x. Okay, now cos 2x, there's 3 formulas for cos 2x. Which one is best suited for this example? It's the formula that has both cos and sine in it, because look at the denominator. The denominator is the clue. The denominator has both sine and cos. So use the formula that has both sine and cos. So it's going to be cos squared minus sine squared all divided by cos x plus sine x. Now, it still does not cancel, because you cannot cancel terms. You can only cancel factors. This one does not cancel at this stage, but clearly for this, cos and cos will cancel. Can you see that? So now, let's see what happens here. We got y is equal to 2 sine x plus, here I got cos x plus sine x in the denominator. But what do you notice about the numerator? Cos squared minus sine squared. Notice that there's a negative sign, and on the left there's something squared, on the right something squared. So this is the difference of 2 squares. That means we can factorize the same. Right, this is the difference of 2 squares. We can factorize. So it's going to be a minus b, a plus b. So we will factorize it. That will be cos x minus sine x, cos x plus sine x. Can you see that? So you have to, besides knowing the formula, you have to know how to factorize. You have to know which double angle formula to use. So now, clearly, that and that cancel. Can you see that? So now, what remains here? What remains is y is equal to 2 sine x plus cos x minus sine x. So y is just equal to sine x plus cos x, because I got 2 like terms here. Can you see that 2 sine x minus sine x will give me just sine x? So that is all. Now I can find my first derivative there. So that's going to be dy over dx. Go to your table of derivatives. So it's k sine f of x. It is 1 sine 1x. The derivative of sine x is going to be cos x times the derivative of x there, which is 1. Remember, f of x, f prime x. You don't have to write down the 1, but the fact is, you need to know that it's supposed to be a 1 there. Then the derivative of cos, what is the derivative of cos? Here's your cos, it's going to be negative sine. So that's going to be minus sine x. Nothing to simplify there. So that is the solution. Let's move on to the next one. Right, our next example here. Again, dealing with trig functions, but not in standard form. So this is not cosec, it's 1 divided by cosec. So you don't see the formula for 1 divided by cosec, you see a formula for cosec. So we go back to our identities now. We need to know that if you have sine x can be written as 1 over cosec x, or cosec x can be written as 1 over sine. What else? If you have cos of x, it can be written as 1 over sec x, and then sec x can also be written as 1 over cos. What else? We can have tan x, which can be written as 1 over cot x. So therefore, cot x can be written as 1 over tan. Also, you know that tan x can be written as sin x over cos x, and cot x can be written as cos x divided by sin x. So those are your reciprocal identities, which are not given to you on the N4 formula sheets. Okay. So if you do not know, you might know the table of derivatives, but you don't know this, you're going to have a problem. So it's only a few we need to store it in your memory. Right, so now I need to rearrange all this into standard form. 1 over cosec is going to be sine of 3x, then 4 over tan will be 1 over tan is cot, so that's going to be 4 cot 3x, and 5 divided by sec, it's the same as 5 cos of 1 over 3x. Okay, because 1 over sec is cos, it's right here in front of you. You can see that? So once it's in standard form, now we can differentiate this. So therefore, dy over dx, the derivative of sine 3x now, the derivative of sine 3x is cos 3x. So it's sine f of x cos f of x times the derivative of 3x, which is 3. Here we got cot, the derivative of cot is negative cosec squared of 3x times the derivative of 3x there, which is 3. And here you got cos. Check your table. The derivative of cos is going to be negative sine 1 over 3x times 1 over 3. So once you get the hang of it, then it's not difficult. But the main thing is it must flow. You must know the formula to make it simpler. So this is going to equal to 3 cos 3x minus 12 cosec squared 3x, and here this is going to be plus 5 over 3 sine 1 over 3x. There's nothing more to do. So this is our final answer. Alright, so now we're going to deal with the next few rules. Alright, so we have been dealing with the standard table of derivatives. Now, the chain rule. The chain rule deals with basically when you have a function of a function here. So the chain rule can be applied to any one of these formulas here, and then also when dealing with exponents. Now let's start with something like this first. So let's take y is equal to k sine f of x. Okay, we know that from the standard derivative there, I taught you that the derivative of sine f of x is going to be cos f of x times f prime x. Now let me show you how it's actually worked out. So this is how it works. So I can use a substitution here. What I can do is I can replace, I can say let u equal to f of x. Okay, so I'm going to replace f of x with the letter u. So I'm going to go therefore y is going to equal to k sine u now. Right, because I'm replacing f of x with u. Now, here I have y with respect to u. So if I differentiate y with respect to u, dy over du, the derivative of k sine u is going to be k cos of u. It's just that it's not x now, it's u. Here, I got u with respect to x. So if I go du over dx, the derivative of f of x is written as f prime x. Okay, now the chain rule formula. I want to find dy over dx. That was the question. So I wanted to find dy over dx. Okay, that was what it was originally. I have y in terms of x here. Can you see that? So dy over dx. How can I use this information that I just worked out now? How can I use that and that? So all I have to do is take dy over du and multiply it by du over dx. Notice du and du cancel. On the left hand side I got dy over dx. On the right hand side also dy over dx. Can you all see that? So now this is the chain rule for dealing with something like this. So what is my dy over du? My dy over du was k cos u. What is my times du over dx? What is my du over dx? F prime x. So therefore, my dy over dx, I can now substitute back for u. So that's going to be k cos of u times f prime x. And what was u? What was u? U was f of x. So this is how you actually work it out, by using the chain rule. You could be asked to use the chain rule to differentiate something like, let's take this one here. Let's go for y is equal to 3 tan 2x. So if we're going straight from the table, okay, if it applies for sine, it will apply for cos, tan, anything from the table of derivatives. So if you are given 3 marks or 4 marks and the question states use the chain rule, then you need to show working here. Okay, so now what I can do here is I can always, my f of x part, I will let it equal to u. So here I can state let u equal to 2x, which is f of x. So always let u equal to f of x from any formula here. So therefore y is equal to 3 tan u. Can you see that? I'm replacing 2x with u. Now here I will find du over dx, and here I will find dy over du because it's y with respect to u. So I'm going to go dy du. So here, what is the derivative of 2x? It's just 2. What is the derivative of 10? The derivative of 10 is going to be sec squared. Now, all you do is write down the formula dy over dx is equal to dy over du times du over dx. And then I do my substitution. What is my dy over du? It was 3 sec squared of u. Here's my dy over du, there's dy over du here, you can see that. Times du over dx. My du over dx is 2. Okay, so now I'm done now. 3 times 2, that's going to be 6 sec squared u. And what is u? U was 2x. So if you are asked to use the chain rule for something that's so simple, you will have to do it this way. Now, it will apply for anything on the table here. You always let u equal to f of x. Alright. Right, so now let's deal with exponents. Let's deal with the exponents. Alright, so now what happens when we have exponents? We haven't dealt with that. When you have your function of x, so this can be anything from your table of derivatives. Alright, so this here could be x, it could be sine x, it could be cos x. How do you deal with something? So now you know your k and n are constants. So now this is the chain rule by inspection. Two methods when we're dealing with exponents. Right, so if I want to differentiate this here, I'm going to go dy over dx. So now, this is similar to the first formula. When you have an exponent, what do? You take your constant or your coefficient, multiply it by the power, so that's k times n. Can you see that? Then you got your f of x, whatever's inside here. You take the power and you subtract 1. But now, remember there's an f of x. So whenever there's an f of x, I need to times and differentiate this and write down my answer outside. So you're dealing with a function of a function here. So you're dealing with the exponent. It's like you're differentiating the exponent first, then you're differentiating what's on the inside. So you start from the outside and then you move inside. So this is by inspection. Let's take an example. Let's say y is equal to sine 2x plus 1. Okay, let's go for sine 2x plus x squared all raised to the power 4. Right, so if I want to differentiate this, now this obviously the grade 12 student won't be able to deal with, right, but because of the trig function, yeah? But the power 4, that means there are 4 multiples of this here. So you're not going to go and write this sine 2x plus x squared, sine 2x plus x squared 4 times, you know, and multiply. It's going to take too long. So therefore we use the chain rule to differentiate. So I check now. My number, let's add a number in front. Let's put it as 5. Any number in front. So now my k here is 5. My n here is 4. My function of x is something from the table of derivatives. It's sine 2x plus x squared. Can you see that? Now, I need to differentiate. So I'm going to go dy over dx. So now how do we do this here? I'm going to go, there's your k, there's your, we deal with the exponent first. So it's going to be 5 times 4. And you've got sine 2x plus x squared there. And now here, 4 minus 1. Can you see that? You deal with the exponent first. So I'm at this stage here now. Times, now remember, your f of x, this is your f of x. So what you need to do is now differentiate this and write down the answer outside here. So the derivative of sine 2x is going to be, you go to your table of derivatives now. Derivative of sine of f of x is cos of f of x, cos of 2x times f prime x. The derivative of 2x is 2. plus, don't forget we got term 2. The derivative of x squared is going to be 2x, and that is a chain rule. It's not difficult. Remember exponent first and then everything on the inside. This is by inspection. Let's simplify here. 5 times 4, that is 20, and then I got sine 2x plus x squared. 4 minus 1 here is 3, and this is 2 cos 2x plus 2x. Let's take another one. Only got a few minutes left here. Let's take another one. So if I got y is equal to the square root of, let me go for log of 3x to the base 2. If I got y is equal to the square root of log 3x to the base 2, first thing I want to do is change this, that square root, rewrite it as an exponent. So now I got y is equal to, I can write this as log 3x to the base 2 all raised to the exponent after. Can you all see that? So now my f of x, my function of x from the table of derivatives is log 3x to the base 2. My exponent here is half. So there's it here. N is equal to half. And then f of x here is everything inside the bracket. So now I'm going to go dy over dx. So I have an exponent. I must deal with the exponent first all the time. Chain rule. So that's 1 times half, which is half. And then I got log of 3x to the base 2. And then here I'm going to go half minus 1. Can you all see that? So where am I at the moment? I'm at this stage here. I deal with the exponent first. I do not enter, I just copy down f of x as it is. Now I'm going to differentiate f of x. So now I'm going to go times, and I need to differentiate log 3x to the base 2. How do I differentiate log 3x to the base 2? Remember, if y is equal to k log f of x to the base a, then y prime, the derivative is going to be k f prime x all divided by f of x times ln a. That is the formula for differentiating log. So I got log 3x to the base 2. The derivative there is going to be, here's my division line here. So that's going to be 3 f prime x all over f of x, which is 3x times ln of the base, which is 2. Right, so that is the derivative of log. Let's simplify this here, so that's going to be half, then we got log 3x to the base 2, half minus 1 is minus half, 3 and 3 cancel here, so I end up with just 1 over x ln 2. This can be simplified further. It can be simplified further here, but okay, let's simplify, although it's not very necessary. So that's 1 over 2 x ln 2 times the square root of log 3x to the base 2. That is simplified. What did I do? I took log to the denominator, sign of the exponent changed, it became a positive half, which is the square root. Right, so we will deal with more of this in the next lesson. So you have to go over a lot of differentiation here.